So now now for the last part, we're going to look at climates with substantial seasonality and polar climates. And so just to remind you what we've done so far, we start with your tropical climates. You noticed as you move away from the heart of the tropics, you start seeing more bare patched lands, slightly drier looking lands. So might even spot a couple deserts. Here we go, like the interior of Mexico. Baja is that desert. Then, and on the west coast, things start to finally get wetter as you get further and further north. And as you move into the subtropics on the east coast, things sort of stay pretty well watered, but in different fashions. Now, as you continue to move more poleward, you see it's all still green, but you're starting to notice because you're on a landmass, and because land masses will cool off much more rapidly when losing heat during the winter and warm up substantially during the summer, we're now starting to move into territory that can get quite cold. And we call this strong seasonal variation in temperatures. We call this continentality. That's why and so these climates that we look at here are continental climates, are all defined by strong seasonality and protracted cold spells. Now, these vary around quite a bit, more than we have time to cover, but it's definitely in your book text as to how long these cold spells last, how long the summers last, how much rainfall they get. Some of these climates will generally get most of these climates are getting their precipitation either year round or during the summer. And so they vary in time of rainfall and length of summer/winter. Winters. And we're not going to go through all these, but some of these actually technically are subarctic climates, sort of in this greater D climate. And so the two we're going to look at are your humid continental. For reference, this is this goes by many different names. You see this sort of like all across the upper mid latitudes. So for example, this is outside Boston, I think, somewhere. Boston, much of the northeastern U.S. Chicago is in this climate belt. Much of Central Europe and Eastern Europe is in this climate belt. Not to mention Japan is in this climate belt. These areas all get really cold, snowy winters, but also can have varying degrees of balminess. So I'm just going to put label this all as a DFA. We're going to be symbolizing this with purple. What's making these climates well watered is that you're generally getting the passage of the polar front. And that's what's controlling the distribution of precipitation and the timing. In some places, depending on various aspects of land cover, land-ocean interaction, and mountain ranges, etc., you get primarily more, the polar front's going to sit over you more during the summer. In other places, like the northeastern U.S., the polar front can pass over you at just about any time. Now, as you start to move further and further north, poleward, you're going to start to get into some climates where it's actually getting where it actually gets. where it actually does start to get much more colder in the winter. You're getting much shorter summers. We're going to call these climates your subarctic climates. So you notice what's happening here is these last letters are changing. The first two letters are basically the same. Much of Alaska is in this subarctic. Much of the Siberia is in this. In fact, my love is right here. You have the greatest seasonality anywhere in the world, greatest seasonal change in temperatures, and the coldest winters anywhere. This is the Lena River flowing through northern eastern Siberia. The town of Yakutsk is not is a little bit further down the river. If you're looking, yeah, you're looking actually south in this picture. That's what's in getting these climates is even though these places look lush, it's kind of an illusion because it looks lush because there's low evaporation. At this point, you're far enough away from the polar front that you're not getting that lift and precipitation except possibly during the summer. So that's going to be quite dry. Let's get to this. So on your polar front is near. So how are we going to call these? So let's put these on our map now. Cool. And as you can see, we're almost done with the map here. So let's see what we'll use the light blue for this one. Right. And finally, last but not least, we're going to be looking at the truly Arctic climates. These are places that are basically frozen year round, do not support much more than tundra Tundra. So tundra, you find this very close to the poles. You also find this on very high mountain tops. Let's say they call it ET. It's so cold, you want to phone home about it. So there's literally is only two climates. There's ET, which is tundra, just means cold, very short, very cold, very dry. Very dry. But this contrasts greatly with the other polar climate, your basically ice sheet. Now you may wonder where that picture was taken that you saw a few months ago. Let's go back to that. This is actually not in, believe it all, California, but you can also get tundra climates at very high altitudes. Oh, by the way, this is what I looked like 11 years ago. I was in better shape and quite a bit skinnier. It is. So finally, climate you have there is the Arctic. So let's write these on the map, and then we're going to call it a wash. Out of tundra, and that's going to go at the top of your map there. All right, I'm going to save these and yeah,